Hey guys, today we are going to do part 1 of 3.6, which is all about graphing quadratic inequalities. So when we're graphing the quadratic inequality, and here we're going to be doing it in two variables. It's going to look a little bit different than what we did back in Algebra 1 for graphing inequalities at the very beginning. But we also did graphing inequalities in, I think it was chapter 5, where we did our lines and we had our boundary and we shaded part of our graph. Here, we know that we're still going to be graphing quadratic just like we did last chapter. It's just that with my equal sign, I'm going to replace that with a less than, greater than, less than or equal to, or greater than or equal to symbol. And you've got some basic steps that we're going to follow here to graph these, and it's pretty straightforward and it should look pretty familiar to you. For this, the first thing we're going to do, graph your quadratic as if it was an equal sign. So we're going to figure out where that boundary happens. We're going to find our vertex, use our 1-3-5 shortcut or whatever process we need to do in order to graph the boundary. And then from there, we look and see if it was a solid line or a dotted line based on what the inequality was. So when we graph those, if it was a less than or a greater than, it's going to be a dotted line that we fill in for the boundary for the parabola. If it was a solid line, if it was an or equal to, then we'll make it a solid line just like we did before with open and closed circles. From there, we have to shade one part of the graph. So I'll show you two different ways on how to do this. One, based on what your inequality is formatted as. If it's y and then your inequality, there's a shortcut for it. But otherwise here, like we did in Algebra 1, we could always do the test point method, where we'll pick a point from one side of our boundary and check to see if it's a solution. If the side is if the test point is a solution, it'll be the shaded part of my graph. If the test point is not part of the solution, then it's going to be the unshaded part of my graph. I made it sound way more complicated than it actually is. Let's just jump into some examples. So in box 2 here, we've just got our regular parent graph. This is just our basic y equals x squared equation here. So when we go through and graph this, we're still going to start with just as if it were y equals x squared. So we know for that one, my vertex is at 0, 0. I'm going to thicken this up a little bit here. Is at 0, 0. Since I don't have anything attached to my x squared, I just follow my regular 1, 3, 2, 3, 4, 5 shortcut on both sides. So from here, this is where the inequality part of it kicks in. So here, since I'm dealing with greater than, just greater than, not or equal to, when I graph this, when I actually plot the points, I'm going to make my boundary a dotted line, meaning that this boundary here, this parabola, all the points on my parabola are not solutions to this inequality because it's not or equal to, it's just greater than. So here, when I graph my parabola, I'm just going to use dotted lines. Otherwise, it's the exact same as what we usually do. Now from here, this is where the two different choices come into play. The kind of the more old school method, the more tedious method, would be picking a test point. Now when I say a test point, you're picking a point on my graph that's not on the boundary, so definitely inside or outside of my parabola, above or below my parabola. And you're plugging those x and y values into my equation, into my inequality, to check and see if it is true or not. If it is true, then that's the part of my graph that should be shaded. If it's not true, the other side should be shaded. So here, I usually try and pick something easy. So maybe we're going to test out, here I'm just going to shade it in red. We'll test out 0, 3. This coordinate right here is 0, 3. If I plugged it into my equation, that would give me 0 is my x value. 0 squared is supposed to be less than 3. Right? My x was 0, my y was 3. If this inequality right here is true, then that's the point. That point should be in the shaded part of my graph, which 0 squared is 0. 3 is greater than 0, so that's true. So this side that has my test point on it should be the shaded part of my graph. So from here, it's up to you on how you want to shade it. I'm going to lighten this up a little. No, I'll keep it as, pale blue. There we go. So all of this inside my parabola should be shaded. Now your other way of doing this, and I'll kind of explain as I'm going through and coloring, because that's fun. The other way to do this is just to look directly at your inequality. Because we have y by itself, we know all of my y values that make this true are going to be greater than my boundary. So since this is greater than, I go above. So I just take, usually I start with the vertex, and I just draw above. That points to the part of my graph that should be shaded. So that's another way of doing it. That's a little bit easier. That's one I usually go with rather than doing a test point. But if it's unclear where it should be going, you can always do the test point just to make sure. Okay, let's move on to boxes 3 and 4. For boxes 3 and 4, the only thing that's going to change is, well, my inequality could be different. Could be a less than, could be less than or equal to, or greater than or equal to. But more so, just let's make sure we remember how to graph all of our different kinds of all of our different kinds of quadratic equations. So for box 3, we're looking at y is less than or equal to x minus 3 parentheses squared minus 4. So in this is in vertex form. Remember, this is your h, which is your x value for the vertex. This is your k, which is the y value for your vertex. Remember, inside is always opposite. So in this case, my vertex happens at 3, negative 4. So that point right there is my vertex. Now, I don't have an a value. Right, I don't have anything out here, so I don't adjust my 1, 3, 5 shortcut at all. I just go right back to how it usually is. So I'm going to go ahead. From here, I go up 1 over 1. I go up 1, 2, 3 over 1. I go up 5 over 1 to get my shape of my boundary. Here it is a less than or equal to. So I am going to make a solid line now. And again, do your best to try and keep it as, let's try that side again. Do your best to try and keep it as, okay, last attempt. If it's still poopy, I'm just going to leave it. That's better. So that's my boundary. I'm either going to have the inside of that graph shaded or the outside of my graph, above or below. Here, you could again do a test point if you wanted to, but we could also just use the information that we're given. We know that all of my y values have to be less than or equal to that parabola, which means I should be shading below my vertex, which in this case, everything below my vertex is all of this stuff to the outside of my vertex. Because all of these points, even though out here where it doesn't look like I'm underneath a parabola, as my parabola extends and continues going up and out, all of this stuff that's not in between my parabola is all still underneath. So it's either going to be outsides or in-betweens. Sorry, outsides or underneath, inside, outside, inside. But it's really above or below my parabola. So that would be what it looks like. Last one, and this is the one that more so we just need to review to make sure we know how to graph this. Here we've got y is less than negative x squared minus 2x minus 1. This is in standard form, so you've got a couple of different options on how you could handle this. If you really wanted to, don't know why anyone would, but if you really wanted to, you could do completing a square on this to try and convert it into vertex form, if that's easier for you. For most of us, we'll just go ahead and do it the way we learned how to do it initially. That's by using my x equals negative b over 2a formula to figure out what my AOS is. So here, negative b would be positive 2, right? Because b is negative 2, so negative 2 is positive 2, over 2 times negative 1, and that gives me, 2 over negative 2, which is just a negative 1, right? Because up here this is a negative b. So negative 1 is my x value for my vertex. If I plug that into my equation, negative 1 squared minus 2 times negative 1 minus 1. Well, negative 1 squared is 1, so make it negative again is negative 1. Negative 2 times negative 1 is positive 2 minus 1. All of that adds up to 0. So my vertex is negative 1, 0. using what we learned initially for quadratic stuff. So once I have that, I'm going to go ahead and, or now that I have that, I'm going to go ahead and plot it. -1, 0. There we go. -1, 0 is right there. Now from here, I can use my a value, so I don't have to necessarily keep plugging stuff in. My a here is -1, so instead of up 1 over 1, up 3 over 1, up 5 over 1, I'm just going to go down instead of up. So down 1 over 1 on both sides, down 1, 2, 3 over 1, down 1, 2, 3, 4, 5 over 1. Now that I have my boundary, I'm going to go ahead and look and see what kind of boundary I have now that I have the shape of it. Here it is just a less than symbol, so it's going to be a dotted line for my boundary. And since it's less than, I'm going to shade underneath, which in this case, because it opens down, underneath is going to be the inside of my function. The inside of my function. And here, your shading doesn't have to be perfect. You can, usually I actually just shade with the same color pen and just kind of do a little stuff like that. That's going to be helpful for us if we shade it like this. Tomorrow, well, not tomorrow. I'm going to record it right away now, but on Monday for 3.6 day 2, we're going to have systems of these quadratic inequalities. So they're going to interact with each other. So we're going to do a little cross-hatching or different colors in order to simulate that intersection. But that's all I got for you for part 1 here. This is just focusing on graphing a single quadratic inequality. So the homework down there is on page 144. For this one, you're doing 3 through 14, 17, and 18, and that's all. So 3 through 14 all, 17 and 18 in addition. So as always, if you have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day.